Have you ever gazed at the night sky and wondered, where do all these stars come from? Each star you see twinkling in the night sky began its life in a nebula. Nebulae are colossal clouds of gas and dust floating in the vast expanse of space. Now imagine gravity, that invisible force starting to pull these gas and dust particles together. As they coalesce, a protostar begins to form. Think of this protostar as a baby star, slowly growing as it continues to accumulate mass from the nebula. As the protostar grows, its core starts to heat up, much like the heart of a living being. When this core gets hot enough, something magical happens. Nuclear fusion begins. This process transforms the protostar from a mere cluster of gas and dust into a shining star, emitting light and energy into the cosmos. So that's how a star is born, from a simple cloud of gas and dust. Now that our star is born, what happens next? Well, it enters the main sequence stage, the longest and, dare we say, the most exciting period in a star's life. During the main sequence stage, stars become real powerhouses. The star's core is a hotbed of activity, where hydrogen atoms are compressed under immense pressure and temperature. This fusion process transforms hydrogen into helium, and in this stellar alchemy, energy is released. This energy radiates outward as light and heat, giving stars their characteristic glow. Picture, if you will, a bustling city that never sleeps. That's the core of a star during its main sequence stage. It's a ceaseless factory, tirelessly churning out energy that lights up the cosmos. And guess what? Our very own sun is currently in this stage, silently burning hydrogen and illuminating our world. It's been doing this for about 5 billion years, and scientists estimate it will continue for another 5 billion years. The main sequence stage is the prime of a star's life. It's a delicate balance, a cosmic dance between the inward pull of gravity and the outward push of pressure from the fusion of hydrogen atoms. It's a period of equilibrium, one that can last billions of years. But like all good things, this too must come to an end. That's the prime of a star's life, a balance of energy that can last billions of years. Before we continue, do you find our journey through the cosmos intriguing? If you're captivated by the mysteries of the universe, consider subscribing to this channel. By doing so, you'll join us on more awe-inspiring voyages into the vast expanse of space. You can also show your appreciation by clicking on the like button. We're dedicated to unraveling the cosmos's enigmas, all in a straightforward, digestible manner. Thank you for your support. Now, let's continue our star's journey. All good things must come to an end, and stars are no exception. But how does a star die? Well, the answer lies in the constant battle between gravity and pressure. When a star has burnt through the last of its hydrogen, it begins to die out. With no hydrogen left to fuel nuclear fusion, gravity gets the upper hand and the core of the star shrinks. Meanwhile, the outer layers expand. The star, once a hot blue, now cools down and becomes a red giant. For stars bigger than our sun, they transform into red supergiants. This is the star's desperate attempt to stay alive, burning helium and other heavier elements in its core to fight against gravity. But this can't last forever. The star's core eventually runs out of fuel, and with nothing left to fight against gravity, it collapses. This collapse triggers an incredible explosion known as a supernova, outshining entire galaxies for brief moments in cosmic time. A supernova is one of the most spectacular events in the universe, a grand finale to a star's life. However, the star's story doesn't end here. Depending on the star's mass, it may become a white dwarf, a neutron star, or, if massive enough, a black hole. A white dwarf is the hot, dense core that remains after a star has shed its outer layers. If the star was larger, the colossal gravity of the collapsing star can squeeze its core down to an incredibly dense neutron star. And for the most massive stars, the core collapses completely, forming a black hole, a point in space where gravity is so strong that nothing, not even light, can escape. So, from birth to death, a star's life is a cosmic journey of transformation and energy, a testament to the ever-changing nature of our universe. It's a cycle of life and death, of creation and destruction, a process that has been happening for billions of years and will continue long after we're gone.